Question 1 says, a particle moves right and left along a horizontal axis. Its velocity at time t greater than or equal to 0 seconds is given by this equation here with units in meters per second. At time t equals 1.5, is the particle moving right or left? Explain your reasoning. Well, believe it or not, this is pretty simple if you know what you're doing. When velocity is positive, that means the object is moving to the right. But if velocity is negative, that means the object is moving to the left. Which means all we have to do is take 1.5, plug it into our answer, and see if we get a positive or a negative result once we're done here. So, okay, let's do this. Let's plug in 1.5. I get 1.167 when I do that. And this is in meters per second, but the units don't really matter. What matters is that this is a positive result, which means that we are moving to the right. Part B says, determine the acceleration of the particle at t equals 1.5. Is the particle speed increasing or decreasing at this moment? Justify your answer. Well, we have velocity here, so if we find the derivative of velocity, we will get acceleration. So we're going to need the product rule here. So we need the derivative of the first piece multiplied by the second piece plus the derivative of the second piece. Derivative of sine is cosine. And then we have to multiply by the derivative of the inside here, multiplied by the first piece here. So, okay, what do we get here? We have sine of t squared. We have plus 2t squared cosine t squared like this. Now we plug in 1.5. So I'm just going to plug this into a calculator here. It looks like we get negative 2.049. So that's the answer to the first part. That's the acceleration. Now, how do we find out if this particle is speeding up or slowing down, essentially? Well, what we're going to do is we're going to compare velocity and acceleration. You see, if velocity and acceleration have the same sign, so they're both positive or both negative, that means the particle will be speeding up. But if they have opposite signs, that means that its speed will be decreasing. And in part A, we figured out what the velocity was. It was 1.167. And right now, we just figured out we got 2.049. So since the signs are opposite, that means that the speed is decreasing. And you might say because of opposite signs, or something similar to that. Part C says, if the particle's position at time t equals 0 is 3 meters, what is its position at t equals 2? Well, we of course have our velocity equation here. And if we want to find the position, what we're going to do is we're going to integrate. Once we integrate, we're going to get a plus c. That's where this first part comes in. You see, by using t equals 0 and 3, we'll be able to figure out what c is. Once we know what c is, we'll be able to plug 2 back in and finally finish this question. So let's go ahead and let's integrate. We're going to be using a u substitution here. And here we're going to let u equal t squared. That means du is 2t dt. And if I multiply both sides by a half here, I figure out that 1/2 du is t dt. And the reason why that is so helpful is because we have exactly a t dt over here. So that means that that part is going to be replaced with 1/2 and du. And then the t squared is going to be replaced with a u, like this. Now we can just integrate like we normally would here, right? The integral of sine is going to give us a negative cosine. Don't forget the 1/2 is still there. And then the u, remember, is t squared, so I can just plug back t squared right here. All right, this is the part where we use 0 and 3. When we plug 0 in for t, we should get 3 out as our answer. So over here, let's do that. Let's see here. We have negative 1/2 cosine of 0 squared plus c is equal to 3. Okay, now the cosine of 0 should just be 1 here. So we have negative 1/2 plus c equals 3, which means that we're going to be adding that 1/2 to both sides. which will give us 3.5. 3.5 is the same thing as 7/2. So we now have our position function. I'll call our position function x. So our position function is x. It's -1/2 cosine of t squared plus 7/2. You don't have to call it x, by the way. You can call it whatever you want. I've seen people use s a lot for position. I'm not really sure why, but that's pretty common. We're essentially done here. All we have to do now is take 2, plug it in. We're going to plug it into our calculator at this point. 2 squared plus 7/2. Okay, if you plug it into the calculator, what do you get? Looks like you get 3.826. And this is position, so this is meters. So that is our answer. Part D here says calculate the total distance the particle travels between t equals 0 and t equals 2. Now, there's a very fast way you can do this. If you have your calculator, you're just going to plug in the integral from 0 to 2 of the absolute value of our velocity equation here. That will give you the answer, but I want to show you a slightly longer way of doing it. So what you're going to do first is we're going to take our velocity function and we're going to set it equal to 0 and figure out what makes it equal to 0. Now, the first piece over here is just t equals 0. Over here, if we set this equal to 0, we have to remember that we're looking for our answers between 0 and 2. So keep that in mind for a second here. What I like to do in these situations is I like to replace t with something else, like a, let's just say. And then figure out where is sine of a equal to 0. Well, that's at 0 and pi. But of course, it's not a that I'm trying to solve for. It's actually t. So what I'm going to do is take my t squared, which is what I replaced a with, and put it back here like this. And if I take the square root of both sides, I will get a plus or minus 0, which is just 0, and a plus or minus the square root of pi. But because we're looking for answers between 0 and 2, I'm going to consider just this here. Okay. Whew. So already, that's quite a bit of work. We're not quite done yet. All we figured out is where velocity is equal to 0 between t equals 0 and t equals 2. Now you'll see I've gone back here and I found our position equation, because what we're going to do is we're going to take 0 and the square root of pi, and we're even going to take one more point here. We're going to take t equals 2 and plug that in, and we're going to see what we get. So if you plug 0 in, that's going to turn into 1. -1/2 times 1 is -1/2, plus 7/2 is 6/2, which boils down to 3. The square root of pi squared is pi, which is -1. That'll turn this into a positive 1/2. That means this will be 8/2, or 4. And then if you plug 2 in, you're going to want a calculator for that one. That's 3.826. Okay, so what on earth have we just discovered here? Well, consider this number line that I'm drawing over here. Now, when we first began, at t equals 0, we figured out that the position was 3. Then, later, at t equals the square root of pi, we were at a position of 4. And then, when t was equal to 2, so let me write it like this. This is t equals 2 here. Actually, let me put it down just here like that. We were at a position of 3.826. So here's how I like to think about it. We started off over here, then we were moving to the right until we got over to here, and then we turned around and we started moving in this direction until we got over to here like this. So in order to find the total distance, all we have to do is think about it like this. What is the distance from here to here in red? And then what is the distance from here to here in green, like this? Well, that's going to be pretty simple, actually. If you take a look here, all we need to do is just do, well, from 3 to 4. Actually, let's do it like this. That's going to be 4 minus 3. And then it's going to be 4 minus 3.826. So we're going to get 1. And then let's see here. Let me plug in this other one into a calculator. Give me just a moment here. 4 minus 3.826 is 0.174. And 1 plus 0.174 is 1.174. So that will be, oh, we should also say the units here. This will be the total distance that the object traveled. Now, if you just went all the way back to the beginning and plugged this in, you would have gotten the same thing, 1.174, definitely a lot faster than this. But you're not always allowed a calculator in these questions. And so this is the whole process you have to go through. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.